All right, so when we're doing problems like this, you're using basically algebraic properties with integrals. So they're telling us what these various integrals are equal to. And so we're going to do algebra with these integrals. So what you're allowed to do is basically distribute this like that, plus integral from -2 to 4 of 4 dx. And now this one, the first one here, we know what that equals because it's right here. So that just equals -6, right? And this one, we have to actually do a little bit of calculus.
Okay.
Or you can just think about what this is saying. And you remember what you learned about?
The area.
Yeah, it's the area underneath the curve. So from -2 to +4, and it's the graph of 4, which is just a line. It's just a horizontal line. So the area underneath the curve right here is basically just a rectangle.
So it'd be 6 times 4.
So it's 4 times 6, 4 by 6, which is 24. So -6 plus 24, because it's a positive area, which equals 18.
Okay.
So that was that one. So for B, what we're going to do here is take, again, we're going to distribute, but now this 3 can come out front, plus, so I distribute, whoops, don't forget the dx there. So now what I have is this again, I can take, that is right here, and that's just equal to 4. So it's 3 times 4, because there's a 3 on the outside.
Where are you getting?
I'm getting...
Oh, there's 2 different g of x's. Okay.
And now I'm adding to that. Again, I can do this a couple different ways. I can either take the antiderivative of this and plug in -2 and 4, but to be honest, this is a relatively straightforward geometric definition. It's just this perfect diagonal line, the 45-degree line, and it goes from -2 to +4. So you know that this is 4, 4, right? So this is 4 and this is 4. This is 2 and this is 2, because it's on the line y equals x. And so this is going to be a negative slope, and this is going to be a positive slope.
Oh, so it would be 12 would be your final.
So
your
remember,
area.
this is going to be 4. This is half of 4, right? Because a rectangle would be.
Oh, the half, yeah. So that'd
So
be
remember,
2.
1/2 of base times height, or just think of half of
Yeah.
that half of that rectangle, or that square in this case.
So then -2 and 8.
So this is -2, and that's +8, exactly. So -2 and +8, and 12.
6. So then 6 plus 12, so 18.
18 is your answer. Now the other way you could have done this part of the problem is you could have done the x squared from -2 to 4 thing.
Okay.
And notice, by the way, how it's the same. You're going to get the same answer. What's x?
That's how he usually does it in class.
And that's fine. Geometric or the calculus way is either way, but it's good to know how to do it both ways and understand what you're doing. So now when I plug in 4 squared minus -2 squared, that's why I get 16 minus 4, which is that right? 16 minus 4?
Yeah.
Sorry, I did this wrong. It's x squared over 2, not x squared. So it's over 2 over 2, so that's 8 minus 2, which is 6, yeah.
Okay.
And that's what I had here, -2 plus 8, which was 6.
Okay.
Okay?
Yep.
So this last one is the trickiest of them all, because you don't really see anything that has a -2 to 0. So here's how you need to think about this one. First of all, you can distribute it, right? -2 to 0 of g of x dx plus the integral from -2 to 0 of 3 dx. Okay? Now this right here, I don't have it here, but if you look carefully at it, you'll see that these things are, what you could do is you could rewrite this as from -2 to 0 of g of x dx plus from 0 to 4 of gx dx.
Okay.
See how you can just build it, you can break this up. This breaks up into those two sections, because whatever gx is, I can start at -2 or I can start at negative 2 and go to 0. And then I can go from 0 to 4.
Well, then
And that's the same as just going from negative 2 to 4 in the first place. So you're breaking up an interval, or an integral, rather.
So then would you plug in
Mm-hmm.
negative 1?
Oh,
Mm-hmm.
yeah.
So this whole thing I know equals what? That
4,
whole
right?
thing. That whole thing equals 4.
And
But
you know
this.
one of them's negative 1.
Mm-hmm, but this piece right here equals negative 1.
So then the other one's 5.
So this piece here has to equal positive 5.
Okay.
That's the algebra of it. So this part right here is just 5,
Okay.
right? And then what's this going to be?
The 3.
Remember, that's going to be, think of it as the easiest way in my
Like 3
mind
times
is
2,
geometric. Yeah, it's
so-
just 3, the line y equals 3, and it's from negative 2 to 0. So it's this box right here, from negative 2 to 0, from 0 to 3. So it's a 2 by 3 box, which is 6. The area of that is 6 because it's all positive. So 5 plus 6 is 11.